Hey, good morning, good evening, everyone. Today we are going to discuss about Java OOPS code examples or object-oriented programming principles. So let's get started. Encapsulation. It is like binding the data methods to operate on the data. It's like imagine you have a treasure box with a lock. You can only access what's inside using the key. Like that, encapsulation is a way to access the data of the class using the methods that we are defined in that class along with the access modifiers. Example, here on the right hand side you can see a Java class with two member variables and one static variable. Just ignore this. We are going to cover this as a part of the last section of this video. Let's focus on these two variables, right? This vehicle class two variables can be exposed to the outside world using the access modifiers. Given these two are private, only the methods, public methods can be able to allow access to these variables. This is how we encapsulate the data so that this data will not be manipulated by other classes or methods outside of this class. Inheritance. A mechanism where a new class inherits the properties and behaviors of existing class. So in the inheritance, we have the concepts like super class, subclass, like a parent class or child class. To give you a best example, think of it as a parent passing down the traits or characters to the child. Like that, the parent class will pass its data members or methods to the child class. Example, let's look at the example, right? This car class extends vehicle. So in this context, in this example, vehicle is the super or parent class, car is the sub or child class. So because car is a subclass of vehicle, it inherits the attributes that are defined in this vehicle class, and also it can call some of the methods based on the access modifier that are defined in this vehicle class. The next concept is polymorphism, the ability of a method to do different things based on the object that is acting upon. In the previous slide you saw in the inheritance we have a child class and parent class, right? So if there is a method in parent class and the same method in the child class, the polymorphism enables these methods to behave differently. Let's take one good example that becomes easy for you to understand. And so, as a part of this, I uploaded the code also. You can get the code from the GitHub repository. I'm planning to share that information in the description, so you can get it and run it locally. Here you can see in this example we have a class called flying car class. This class extends vehicle class. So vehicle class is the super class or the parent class. Flying car is the child class or subclass. This flying car has two attributes along with the attributes that it is going to inherit. If you look at, there is a method called start method. Here we annotated with override. That means the same method is there in the vehicle class also. We are just overriding this method saying that, hey, this is a flying car. So flying car started. In the vehicle class, we might have said vehicle class started. I will go to the example and show you by running these programs as a part of this video. Just hold on. These are the concepts first I want to introduce, like how we are doing this on our series. Okay. Hope you understood. So the polymorphism is the way so that these methods are overridden. The same method in the vehicle class says vehicle started. In the child class, it says flying car started. Based on how we create the instance of this class, the corresponding methods will be invoked. That is polymorphism. If you don't understand, that's fine. When we go to the example, when I run the example, you should be able to see it clearly. Okay, let's move on. The last concept of object-oriented programming is the abstraction. There are other concepts, but this is the core concept of the object-oriented program. What is abstraction? It's a concept of hiding the complex implementation details and showing only the necessary features of an object. So, example, on the right hand side, we can see the example, right? Start and stop. So, when an object is invoked or created, and this method is invoked, like object dot start, user will see only this information, vehicle started. They will not see the details of what we are doing. The abstraction is a way to make sure the information is clearly concise and really not exposed completely. Only the user knows. To give you a real world example, assume that you have a Tesla car, right? The Tesla car, when you hit the accelerator button or the pedal, the car will accelerate. As a user, you don't know how much battery energy it is using, because as a user you don't want to. You want to know where is that button and how to use that accelerator button. So the information about the detailed implementations of the acceleration is abstracted for you. Similarly, in the object-oriented world, when a method is defined, the information and the details about the implementation are abstracted. If we are inheriting or we are deriving the class or overloading, overriding, all that kind of scenarios, the abstraction plays a very important role. Hope you understood that. Okay, now let's move on to another important concept called overloading and overriding. Okay, overloading is the ability to define multiple methods with the same method name but different parameters. The name of the method is same but the parameters are different. Okay, example, stop method in a vehicle class and car classes. We will see that example. Okay, what is overriding is providing a specific implementation of a method in a subclass that is already provided in one of its superclass. So just to simplify, overriding means in a superclass if there is a method start and in the subclass there is a method start, we already saw. In the subclass the implementation is different and the superclass the implementation is different. In our example, the vehicle class start method is having one implementation, and in the child class car we have the start method with different implementation. So example of overriding, yeah, see, it's the same start method that what we discussed. On the right hand side we can see here we created the objects and we are calling the methods on these objects. Let's take this last concept, static variables. Once we are done with this slide, we'll go to the code and we will just run and execute the program and see that. Okay, what are static variables? Static variables are shared among all instances of the class. Let's take example. We have a class called vehicle. We can have multiple instances. One is truck, one is a car or flying car, sports car. Different instances are there for that class. If we want to know how many instances are created, we need to define a shared static class. Static class is a shared memory among all the implementation. You can think that way. Okay. So on the right hand side, you remember in the first slide of this video, I told that just ignore this last attribute or member variable. This is a static. Here you can see static number of vehicles. So in the vehicle class, if we want to know how many number of vehicles are there, means number of objects created, we define them as a static. So for this vehicle complete class, there will be only this static method. Whenever there is a new object is created, we will increment the number so that we can keep track of it. But whereas these two things, member variables, they will have their own instances for each object. So object will not share this information, whereas the objects will share, vehicle objects will share this information. If we increment it, that gets incremented. If we decrement it, it will be decremented. It's like a variable that is available to all the objects of vehicle class. Hope you understood the concepts. I know if it is not clear, that's fine. We are going to use this and run the program and see what exactly we discussed about. So we discussed about the vehicle class just now. So we have this is a parent class. Car is the subclass. We know car is a subclass. How? Because car extends vehicle class. And there is another subclass called flying car. This also extends vehicle. Right? Let's run this program. This is the main program. As you know, we have a public static void main. This is where the Java or JVM will start executing. So as a part of this first step, what we are doing is we created an object called car for this vehicle. And you see, we are having new car. This object car object refers to this class, car class. The vehicle flying car is the object name. It refers to, it is an instance of flying car class. So we are passing these values: model BMW, number of seats 5, fuel type petrol or gas. In the flying car we have sky cruiser and electric. This is how those two objects are constructed. Right? When we say car dot start, there is a method in the car class called start that will be invoked. In the flying car also there is a method car start that will be invoked. When we call stop, this is a overridden method. This will be called. Let's run this program and see what output we get. Based on that, we will try to explain. Okay. As a part of this execution, car dot start, car started, flying car started. So we got the correct information. Here, though we called car dot stop, why did we get vehicle stop message? How do we debug this? Okay, let's go to car class, right? And we need to look for the method stop. Do we have a method stop? Yes. So, but this stop method is having a parameter, but when in the program we call it just stop, there is no matching method. So let's go and check whether in the vehicle do we have any method just to say stop. Yes, here we have a method says stop. That is the reason when we invoked car.stop, we got this vehicle stopped message, because the stop message with no parameters is not available in the car, but it is available in the vehicles class. There is a method in the car class called stop that takes a parameter is emergency stop. So in the next line, when we called car.stop is emergency true, this is when this emergency stop message came. Let's go back and see in the car.stop. See here, emergency stop, emergency stop. This is how overriding and overloading works. So as a part of this, we are able to demonstrate subclass, superclass, inheritance, polymorphism, overriding, overloading, encapsulation. The last piece is the static method. Here, as a part of line number 15, when JVM or Java executed this line, it printed number of vehicles created 2. So here you can see we created 2 objects. That is the reason the output is 2. Let's go and check it out how this display number of vehicles is written in the vehicles class. Let's go. Here, okay, what is this? We are trying to print number of vehicles created, this variable. What is this variable doing? This variable is declared here. You see here, this is the trick. In the constructor, they are incrementing it. That is the reason we are able to see 2, because the vehicle constructor called two times when we created two objects. Hope it is clear to you. If not, please go back and rewind this video. If you still have questions, please write a comment. I will reach out to you and explain one-on-one if possible as soon as my time permits. Okay, preferably in 24 hours or 48 hours. Thank you so much for watching. Looking forward to talk to you in my next video.